A uniform lamina is a shape cut out of a flat sheet of material. It is uniform because the density of the material is regarded as being evenly distributed throughout. The term lamina indicates that the thickness of the material can be ignored. Students, today our topic is centers of mass, composite lamina. Welcome to my channel, DNA.12 Education. Okay students, now we're going to discuss about the composite lamina. If you hang a shape from a single point, you know that the center of mass will always rest directly below that point. So if you hang a shape from two different points, one at a time, and draw a line straight down from its point, the center of mass is where those lines intersect. Students, for symmetrical objects or regular objects, finding the center of mass is relatively easy. For example, for a rectangular picture frame, you know the center of mass is in the middle of the rectangle, and you can find that with a ruler. Okay, students, look at the example 1. I will show you this rectangle. Okay? To find the center of mass of this object, I think that's very easy. The easiest one to find the center of mass is by drawing the intersecting line from the first diagonal to the second diagonal, right? Okay, from these intersecting lines, we'll find this dot is center of mass of this rectangular. That's very easy, right? Okay, next. Now we're going to look example 2. Okay, what about this square? With the same method, we are going to find the center of mass of this square by drawing these intersecting lines from diagonal to the second diagonal. Finally, we found the intersection point. So we call this one center of mass of this square. That's very easy, right, everyone? Okay, students, talking about the center of mass, for this topic, we're going to make it precise. By drawing the XY axis from origin OO from the left, and we know that here that this rectangle is OABC. OABC. We can find the center of mass of this rectangle is a half OA as a base and a half OC as a height. Or we can write the center of mass of this rectangle is a half of length and a half of width. So we can take the conclusion that the center of mass of this rectangle is G, a half OA and a half OC. A half OA is X representative and a half OC is Y representative. Okay, students, what about this square? Look at to the example 2. With the same way, we will find that the center of mass of square, that's very easy, right? We can name this square with the letters OKLM. OKLM. So we can note that center of mass d square is a half OK and a half OM. As you know that OK is side of square and OM is side of square as well. We know that the characteristic of the square is its side is the equal side. So we can take the conclusion that OK equals to KL equals to LM and equals to MO. So center of mass of this square is a half OK and a half OM. Or we can write a half side and a half side. Is it clear to you, everyone? Okay, students, now we go to the next topic. To make it clear about this material, I will show you another shape. We call this one circle. The easiest one to find the center of mass of circle is to put the intersecting line. Look at the dotted line. Yeah. Directly, the center of mass is found. Look at the red dot. Okay, we can say that this one is center of mass of the circle. Next, we go to the triangle. What about the triangle? Yes, that's very easy. By drawing the intersecting line from corner to the corner, left, right, and from the top, we will find the center of mass as the intersecting line. That is the red dot. The red dot is the center of mass. Is it clear, everyone? Okay, to make it clear how to find the center of mass of those objects, we can draw the XY axis on the center of mass of the circle. We found here that the center of mass of the circle is 0, 0. Is it right, students? Okay, what about the triangle? Yes, we can draw the XY axis as well. Look at the origin point, O, yeah, at the left side. As we know, this one is base of a triangle. Let's say it is B. And this one is the height of the triangle. Let's say it is H. Okay, students, that's very easy, right? So, the center of mass of this triangle is a half of base and a third of height. Once again, a half of base and a third of height. So, a half of base is representative of this x-axis and a third of height is the representative of the y-axis. So, center of mass this triangle is a half base, comma, a third height. Is it clear, students? Okay, students, now we're going to continue to the next material about the composite lamina. The term lamina indicates that the thickness of the material can be ignored. Okay, I want to give you one example how to find the center of mass of the composite lamina. Look at this diagram. Okay, students, to find the center of mass of this composite lamina, that's very easy. Just follow these 4 steps. The first, draw the XY axis diagram at the left. Let's say 0, 0. Step 2, separate or divide the lamina into the symmetrical object. Make it simple. Step 3, find the center of mass of each symmetrical object. Let x1, y1 for the first object, x2, y2 for the second object, x3, y3 for the third object, and etc. And step 4 is use the formula to find G. So what's the formula? Okay, I'll inform you later. Okay, students, now we're going to solve this question. The first is draw the xy axis diagram at the left 0, 0. Already, look at the red line diagram, xy axis. Clear, students? Okay. Next, step 2 is separate or divide the lamina into the symmetrical object. Look at this diagram. That's very easy, right? The first object is the red line, right? The second object is the green line. Is it clear to you, everyone? That's very easy, right, everyone? Okay, students, we already got two objects, the symmetrical object. Let's say the red object is A and the green object is B. Okay, students? Next, the third step is to find the center of mass of each symmetrical object. Okay, students, look at this object A. The easiest one to find the center of mass of each symmetrical object is to draw the diagonal line. Yeah, find the intersecting point by drawing these diagonal lines. I repeat again, students. Can you see that, students? That's very easy, right? Okay, students, we found the dot point in the center of this object A. Okay, students, now we are going to step 3. Find the center of mass of each symmetrical object. Yeah, let x1, y1 for the first object, x2, y2 for the second object. Okay, students, based on this diagram, we found that there are two objects, the red rectangle and the green rectangle. Okay, students, how to find the center of mass of each symmetrical object? Okay, the easiest one is to draw two diagonals from one corner to the next corner. Okay, yeah, this is the first diagonal and this one is the second diagonal. We found that the center of mass of this rectangle is black dot. Is it right, everyone? Okay, students, now our job is to find the x1, y1 for this red rectangle. Students, to find x1 and y1 should be respected to the origin. Once again, x1 and y1 respected to origin point. I mean 0, 0. Okay, now we're going to find the x1 first. Okay, this is the x1. Can you find the length of this horizontal line? Yes, that's very easy, right? For the x1, we found that that's 3.5. How you know that 3.5? Okay, look at this one, everyone. we found here this one, x1 for this rectangle A. Okay, is it clear, everyone? I think you agree with me. The length of this line is 3.5. 1, 2, 3. So here is 3.5. Is it right, everyone? Okay, that's very clear, right? Okay, next, we go to y1. Okay, we go to y1. For the y1, we have to draw the horizontal line, right? Can you guess what is the length of this horizontal line respect to 0, 0? Yes, that's right, 5.5. Okay, I'll show you how to find 5.5. Okay, look at the y-axis, 0, 1, 2, 3, 4, 5. Okay, so I think you agree with me. Here is 5.5. Is it clear, everyone? So the length of this y-axis for object A is 5.5 units. Is it clear, everyone? Okay, good. So what is the next? Now we go to the next. Now we go to the green rectangle. By the same method, we have to draw the diagonals. And then we found the intersection point that center in the rectangle, right? We found here that this one is black dot in the center of the green rectangle, right? Okay, now our job is to find x2, y2 respect to origin 0, 0. Okay, the first is to find x2. This one is x2, right? Respect to 0, 0. Can you guess the size of this line? Yes, you're correct. The length of this distance is 7 units. Right? 7 units. So I will show you how you got 7. 0, 1, 2, 3, 4, 5, 6, 7. Do you agree, everyone? 7 units. Respect to 0, 0, we found for the x2 is 7 unit, right? Okay, so what is the next? The next is to find y2, right? How to find y2? Okay, I'll show you this one. This is y2. Can you guess the distance of y2? Yes, right. The distance of y2 is 4 units respect to 0, 0. Okay, I'll show you how it works. 4 units, this one. Do you agree, everyone? That's 4 units? Good. Okay, 0, 1, 2, 3, and 4. We got 4. Right, everyone? Okay, good. So what's the conclusion? Okay. The conclusion is center of mass object A is 3.5, 5.5. And center of mass object B is 7, 4. Okay, we got the center of mass of each symmetrical object already. We can say this one, 3.5 is x1, 5.5 is y1, 7 is x2, and 4 is y2. Is it clear, everyone? That's very clear, right? So next, what is the formula? For dx, or center respect to x, for this composite lamina is area 1 x1 plus area 2 x2 plus area 3 times x3 plus blah 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 divided by total area of this composite lamina. Once again, a1 x1 plus a2 x2 plus a3 x3 divided by total area of this composite lamina. Okay, so what about gy? a1 y1 plus a2 y2 plus a3 y3 divided by total area of this composite lamina. So this is the formula to find center of mass of this composite lamina. Okay, so then because we have only two rectangles, so gx is a1 x1 plus a2 x2 divided by a1 plus a2, and gy equals to a1 y1 plus a2 y2 divided by a1 plus a2. Is it clear, everyone? Okay, next, we are going to finalize this question. Okay, now we're going to the next step. Okay, the next step is to finalize this calculation. Okay, the final center of this composite lamina. Okay, center of mass object A already we got is 3.5 and 5.5, and center of mass object B is 7.4. As I mentioned before that, 3.5 is x1, 5.5 is y1, 7 is x2, and 4 is y2. Okay, this is the information. Okay, next. The area of object A is, this is the area of rectangle, right? 6 minus 1 times 7 minus 4, we got 15 units square. And the area of object B is 8 minus 6 times 7 minus 1 equals to 12 units square. Is it clear, everyone? Okay. Okay, I'll show you how it works. Okay, for the red rectangle. Okay. Okay, this is the length of this red rectangle is 6 minus 1. 6 minus 1. Okay, and the width is 7 minus 4. This one is 7, right? This one is 4. So we got here is 7 minus 4. Is it clear, everyone? Now for the green rectangle. This one is 8 minus 6. 8 minus 6, right? And for the width is 7 minus 1. 7 minus 1. Right? This is 1 and this one is 7. Okay? So this is the area of the rectangle. Length times width. Is it clear, everyone? Okay, next, we can continue this one. We are going to finalize this question. Okay, Gx is A1x1 plus A2x2 divided by total area. And by inserting the data, we got 15 times 3.5 plus 12 times 7 divided by 15 plus 12. So Gx is 5.05 units. Okay, what about Gy? The center of mass respect to y. A1 y1 plus A2 y2 divided by total area. 15 times 5.5 plus 12 times 4 divided by 15 plus 12. We got Gy is 4.833 unit. Once again, Gy is 4.83 unit. That's very easy, right? So the center of this composite lamina is 5.05, comma 4.83. Is it clear, everyone? Okay, hopefully the material is clear for you. Thank you for attention and your time towards this video. Center of mass for composite lamina. Bye-bye.